When we buy a new lathe, it typically has a 4-way tool post at best. If you're lucky, the lathe will include a quick change tool post as standard, but this is generally only on the premium models. My lathes came with a 4-way tool post, and I have to say that over the years I've gotten used to them and I find them both easy and intuitive. That being said, a quick change tool post is today's standard, and if you don't currently have one, then you will likely go out and buy or even make one. That might go a long way to alleviate the problems associated with setting tool height, but it does introduce another issue: where and how to store the tool holders. Some people prefer a tool holder for each tool. This means that each holder can be set to the required height for the tool mounted. No more adjustment needed, but that means a lot of tool holders. However, if you need to move tooling between different lathes, then that system just doesn't work. I move tooling between my lathes, 16mm for the Sheraton and 20 and 25 for the Colchester and Toolmaster. The Toolmaster does take 32mm tooling, but I don't have any and don't plan to purchase any currently. Traditionally, I've kept tool holders in the drawer, but that's messy, cluttered and lacks structure and order, and that just won't do. I've seen several people make a shelf for the back of the splash guard and store them there, but I'm not a fan of reaching over a working lathe to select the next tool. It's not a place I want to be. For the Toolmaster, a blank tool holder is a little over 2 kilos, and with a tool mounted it can be over 3 kilos, which is nearly 7 pounds. Multiply that by 10 tool holders and you can see why this makes me uncomfortable. Many years ago, my lifelong machining mentor and friend, who was my high school teacher, made a storage tree for his Colchester Triumph 2000. This video shows my build of his idea. G'day and welcome to the Outback shed. I'm going to build one tree for the Colchester and another for the Toolmaster. I may do something different for the Sheraton, but not at this time. I've laid out some tool holders to get a feel for the sizes. 3 layers of 4 should be enough, but the tree must be stable and not prone to falling over. It must be as narrow as reasonable to take up the least amount of bench space. The tool holders must be easy to remove and refit without disturbing other tool holders, even if tooling is installed, and it should provide the opportunity to store tool post spanners. As I will be treating this project as a dual build, I'll generally only show each aspect only once. Just assume that I'll be doing everything twice. I'll select the best footage for the video, so I may jump from one tree to another from time to time. From the bench mock-up, I will make one tree 300mm high and the other 400. Raw materials come mostly from what I have, but I did need to purchase the bearings. The tubing I have on hand is 115 by 5 and 3 inch by 1/8. The flat bar for the branches are 50 by 8 and 30 by 6. Aluminium offcuts for the top cap and bottom plates are 120, and I also have some aluminium bar stock of varying sizes that I can use for spacers, washers and nuts. I purchased the bearings, and the bottom bearings I'm using 19mm internal diameter, as I'm going to use an offcut of stainless steel bar. The outside diameter is a little over 40, but that's not important as the seats will be machined to suit. The top bearings are 12.5mm internal diameter. The first job is to mark the tubes and cut them to length in the bandsaw. The saw cuts leave a sharp burr both on the inside and outside of the tubes. I'll remove these with a power file, which is a great tool for this job. In a 4-jaw chuck, I'll centre it as best I can, bearing in mind that the tube is not perfectly round. The outside's not important, but I do need to skim the inside to get it round so I can machine the cap and bottom plate to suit. I don't have a finished diameter in mind, only to remove the minimum amount to achieve the fit. A couple of tenths is about as close as I can expect on this type of material. The internal scarf has not been removed in these tubes, and you can hear the tool clicking as it cuts into it. This is a result of the tube making process. The tube starts its life as flat stock. It then goes down a process line with roll stands that form the tube into a circle. This is then fusion welded in a continuous process to form a tube. The external scarf, which is a remnant of the weld, is removed with a carbide or ceramic scraper. Some tubing is manufactured with the internal scarf also removed, but not on the pieces that I have. I'll deburr the edge with a deburring tool. It's then wash, rinse and repeat for the other end of the tube, and the same for the other tube. The larger tube is too big to fit in the spindle, but it does fit inside the 4-jaw chuck body. That leaves me with a little over 300mm stick out, and with light cuts that works fine. After a clean up with the vacuum cleaner, it's off to the mill to drill the 6 mounting holes in each end of the tubes. These will be used to attach the trunk to the top cap and bottom plate with 6mm socket head cap screws. I'm not a fan of using compressed air for cleaning. Apart from it being poor practice to use air on a lathe, all it does is relocate swarf from one part of the shed to another. Eventually it will need to be cleaned up, and that will be more difficult due to it being scattered all around. I prefer to use a shop vac. Time to power up the mill, turn on the air and fit a drill chuck. I set the tube up in a divider to space the 6 holes in each end. The end of the tube is supported by a V-block. I was going to machine the end caps on the Toolmaster with the outside jaws, but the 270mm chuck is too large, so I'll use a Colchester instead. I have a 160mm 3-jaw chuck mounted, but it also looks too big, so I'll change that for a 125. I have a bed stop mounted so that the carriage cannot go any closer to the chuck. I have set the feed to reverse, so I'm cutting away from the chuck and towards the tailstock. After centre drilling, I'll run a 6mm pilot hole before drilling the hole to 29.5 with a Morse taper drill. I've noticed of late that the larger drills tend to cut heavier on one side than the other, always on the far side of the drill. This is giving me the impression that the headstock is slightly out of lane with the tailstock. I'm not sure it's a tailstock alignment issue, as the lathe cuts parallel with the centre installed. Looks like a maintenance day is coming up and I need to do some re-levelling. This lathe is just sitting on the floor and is not on levelling feet. I have doubts about the level of this part of the concrete floor. I'm going to use a boring bar to bring the hole to final size of 30mm. The clearance hole is now to size, so all that's left to do is cut the bearing seat. That's a good fit and I'm happy with it. Now I'll turn it around and finish off the other side. I'm now machining the recess for the trunk, then I'll cut the top cap. Next I'll cut the top cap and bottom plate for the small tree from some bar stock. I've machined the top cap for the small tree. I'll give it a decent chamfer and a polish with a piece of Scotch-Brite lubricated with some WD-40. I'm not comfortable with the mounting, so I think I need to change to get a smaller chuck. I'm fitting an 80mm 3-jaw. It's the smallest chuck that I have. I have on occasion seen a small 3-jaw held inside the jaws of a larger 3-jaw chuck, but that's something I wouldn't do. If a chuck is good enough to use on your lathe, then it's good enough to have its own backplate. That's finished the bottom face of the cap. Now I just need to machine the recess to allow it to fit into the trunk. I'm not happy with how this tool is performing. I'll change it for another edge. That's cutting better, but it's still not producing a good swarf. I still wasn't happy with the quality of the cut, so I changed the insert off camera and it's made some improvement. Well, that's it for part 1. Please join me again soon for part 2. Thank you for watching. Be productive, be creative, and most importantly, be safe in your shed. Catch you next time.